I'll start with data science. Okay, I'll start with modeling. The first people coming of the Earth, they try to make some models, maybe drawings or with paper, some models. After several years, it came mathematics, and people start to make mathematical models. After that, it came computer science models. Computer science models are more powerful than mathematics model because in computer science you can write whole programs describing some process than only formulas. And nowadays it came data science. This is not new science. You know, computer science it came in 1960s. From something like this, 1970s, it used mathematics, engineering. Now it came data science. Data science is, you have the data, and now using the data, the model came from the data. So you have to have some idea what you have to search, otherwise you will not find real output. But nevertheless, nowadays, the most important, the most valuable things in the earth are not the petrol, not something else, are the data. You pay more than for data, more money than for gold. So, and data science is the science that is study the data and trying from the data to find some rules to predict what will happen in the future. In the data science, people are using all kind of data, structured, non-structured data, text data, image data, several language. The most important, the most usable language is Python. Why? Python is very bad design language, the worst design language. But the most libraries for data science are in Python. So we use Python, most of the people. And now data science is studied in all university. Why became a data science? Its demand. It said that in the next year, 11.5 million new jobs will be developed. It's very high paid. The senior data scientists take around $138,000 US for a year. Data science makes data better. I will speak about data, curation, all this stuff, but I will speak in the way that you have the data to prepare the data so the AI can immediately use it. Makes products smarter, can save life. It was, you know, there are so many hospitals in the world, places people are going, and all the data are private for the hospital or medical center. The biggest step was done last year when the model can be done before any medical center, they don't allow the data, even they're anonymous without name. But now the new trick is designed. You gave the model in the medical center, they train the model with their data and give them the result to another center. So, because in this way you don't have idea what's the real data, but in this way I hope in very, very near future the medicine will go much faster. Different data, personal data, you have music, you have images, picture, everything. And now the data. after this nice presentation of Milena, I will start from the data, how to curate data. First is you collect the data. Where? From where? Everywhere. TV production, newspapers, research papers, everywhere are data. So it's very restricted for people working with science to go only with scientific data, because a lot of data, real data that can be used in your research can be found in many other places. So you find the data, you clean the data. The data are not clean usually. If you don't clean the data, your results are fake. And you have to transform. So I go further in these steps. Also, you have to organize the data in some way using database, spreadsheets, different system. If you have the data, the most important is for to put somewhere where to can search the data, easy search. It doesn't matter where. But if you don't have, for instance, some ministry, I don't say your ministry, they collect papers nowadays. The Bulgarian Academy of Science, the central bureaucracy, they collect papers. How they can search this paper? Nowhere. Nowhere. There is no value of what they are doing. Okay, this is another story. So, management the data, different steps. Okay, and now you have the data. They're coming in different data formats. Why so many formats? Why? Can we go in one format? Maybe, yeah. But the best thing is you can go in super format and then to keep the lowest format, because all of them, they have different characteristics and they are designed for different particular fields. And I will say that very often used for research data are Excel files. This is example about Titanic. People of Titanic, the name, how much they pay, and so on. And it's very easy format, and many researchers are using. XML is nice thing. People are thinking it's new. It's not new. It was before XML. They make XML, HTML. Before HTML, XML was defined. So here is an example. You define some movies. You define the star, the name, the address of player, and so on. XML, it's very nice when you put some text data. Never mind what kind of text data. In this case, you make this data more searchable, because you specify where is address, where is the name, where is, if it's letter, the date, and so on. So using some structure that you can put in the text, even non-structural text, you can try to structure, and using XML in the search process. JSON is very nice format. It looks easy. Here is name and so on. It's very often used nowadays in search engine. For instance, in this way, when you want to ask for some street in your cell phone, what you see, if you are in very big crowd, the result is coming slowly, because the process is going down. it's asynchronous, so JSON file is putting in some place where the process is done, the search of the map, and it's going up. In the same time, the next step of our request is done. Okay, web pages. Web pages, you know web pages. Doesn't matter what is web pages. All of them nowadays are in HTML. So I asked my student to find one HTML file about Olympic Games and to extract the names, the records, and make their own. So it's very easy to see the structure. You push the button, every HTML browser sets what is structure, something like this, depends on the browser. You see exactly the places where the different things are inside this document. So you can extract and make your own nice picture. And the best thing is not one HTML, one web page. You have several web pages. So easy thing that the people are became millionaires nowadays. It's finding several public, most of the sizes are public, extract the data and make the new presentation of data from different sizes, and you use them. Text files, text. What is text? Texts are words. And how you can, non-structure usually, but how you can search text like Google and other search engine. So you have to present every word in some way, then the whole document, like one point in n space, and then you search in this way. I have some examples. Image formats. There are many image formats. I personally work with images all my life. And there are raster and vector formats. TIFF is very nice format because you present a lot of characteristics of image. It's used usually in medical images. You know, usually you use JPEG and GIF. Pink was introduced many years ago because theoretically, not practically, JPEG and GIF have compression algorithms for which you have to pay. Nobody's paying, but that's why they produce pink. Also, you have to present your image like graphics. SVG is fantastic language made by Adobe. It was supported with old browsers, not nowadays, because they have problems with Adobe. And you draw the image, said I have circle, I have triangles in some color, moving here and there, and it was so nice. Data series. Data series are another way to present data. This is an example of stock market about Tesla. Tesla is a very nice example for students. The best example about stock market is Tesla. There is no other stock which is going so fast up and down. So for analysis, student analysis, all these data are public. You can immediately upload. So no, and here it's the price, the beginning and the end, what is the stock. And for data series is another story. Usually you don't use SQL or it's better to use non-structural, not database which is more simple because it's not necessary to draw the whole relation. So non-relational databases are more often used for this purpose. So data cleaning, I'll go this. So you have the data. You find the data for somewhere. First, you can remove the missing data. This is not the best way because you remove not only the missing data, you remove the whole tuple. So you remove. So better is to replace the missing value with mean, media, and so on. Remove duplicate. You collect data for several places, so you have duplicate. Standardization. It's also very important because if you use, let's say, data, coming from American standard is month, day, European is day, month, and so on. Using some numbers, they have to be in some there is a nice example about one of the first American satellites. When they came back on the Earth, it crashes. It crashes because the software was designed in UK, and the UK in the American, even the inch, and it's different. So you have to take care about all this. So you have to standardize the data format, convert the text in some way, and also to standardize the units. So normalization. Now, I present so many different data, but our goal for all the data is to convert in numbers, because all algorithms working with analysis is with numbers. Even more, most of this algorithm working with integer only. So even the text, even the music, even the picture, everything, our goal is to normalize. Easy way is, this is example of renting company. It has price, room, neighbors, and neighbors is airport, downtown, and so on. So you have to introduce new columns. If it's airport, if it's downtown, 0, 1, so you convert all these texts in numbers. Here, more deep. If you go in text, you have it's simple problem of evil horizon problem. So you use so first all the words. You think all the words are in one vector. You convert your text how many times each of these words is presenting, and then you use TF, IDF model, which based on term frequency and document frequency. It was produced by the people they make Google. Before Google was AltaVista, many other things. Why Google? Because they try to use statistics on based on statistics. So every document using this method, for every document is connected to one point in n space. Here is, and then you use sign, like measure of this point and the point which is your query. Your query is also transferred in this way. You use why cosine? Why not Euclidean? Because Euclidean you have square root. Square root is very time consuming to calculate. And cosine is very easy. You have only product. So here are examples how you use. And then your data are converted. So you clean, you correct the data, make nicer, then you transfer, and then your data is easy to go to analysis. For instance, neuron analysis. So here I put the formulas. Here is one example that I put here that my students are working. You have 50,000 reviews, which are separated in two parts. One is used for to find the modules, another are to see how correct is the modules, and then if you have your new review in the paper, immediately you can see how good or bad is the movie, to go there or not to go. Here is another example of using to find, which is only 3 lines caught in, you see. You have NBA players, and you can see which is the nearest to some player. This is, in Python, you write only 3 lines. Okay, so we have the data, we clean the data, you make nice. Then we analyze the data. And then the next thing is to present the data. Because people, they are lazy. They don't want to read. Even if it's more higher level boss, forget it to read something. So you have to present in a nice way. So you use some way to present the data. And here, only the nicest thing of presenting the data, you have to know how to present it. To tell the reader what you have. Here, you see this thing here. Nobody is telling to start from 0 to some. It can be spread for 1001 until 1002, and then you see that the result is very near. People said, "Oh, this is nice." If you want the result to be far away, you make the scale bigger. So all the presentation is strict. You don't. Why? Here are, and there is another language which is also used in data science. It's R. R is very nice language for presenting. People are using also for many other things. Here are examples that my students have done. The first is the map of the states since earthquakes. The second is where more water is you have in the United States. The last is the map, and you put in different color the election results. So I start with data science. I hope, I'm not sure, but usually what I hope until now in my life is coming. New science is coming. I don't know. You don't know that is coming. This is intelligent science. Essentially is system organization and control, neural and cognitive mechanism, contextual understanding, social and value system. So these are the parts. So what give me, this is not my ideas, only mine. What give me the things that this is coming? The idea is that until now, you have the science. On the basis of science, you have technology. On the basis of technology, you have engineering. Nowadays, using AI, you have engineering, technology, and this is science. So here, new science has to come to make the AI more powerful. Not here. Here is enough. All these methods are for 1960. Guys, nothing new in AI is coming from 1960. The only thing, the computer are more powerful, and you can make example with thousands of layers, not with one layer or two layers. Okay. To finish, I want to say some words. This is one conference that we're organizing. This will be 15 this year. It's in Burgas. It's under logo of UNESCO. The day when the conference is finished, the same day, it's indexed in Scopus in Web of Words. The same day. Even the people are inside the conference, it's indexed over it. So and always inside this workshop about open access to scientific publication and so on. So this kind of people here, I hope they can contribute and send papers and so on. Thanks.